Sometimes while you are executing a program, various events will occur, and these events will be out of the context of the program, which means you didn't write or you didn't expect that such an event will occur, and suddenly that event has occurred and you don't know what to do. For example, in your program you have written a statement which is trying to divide a number by 0, or let us say you have written a program which is trying to access a memory location using some absolute address, and that address is actually not your part, which means if your program is trying to access some memory which is not under your control or which is not allotted to you, then your program, you cannot expect such events, and so you didn't write any code to handle that. So most of such things will be handled by operating system. Anything out of ordinary, if it happens, that is called an exception or interrupt, or let's say that is called an exception. And whenever such an exception happens, either because of your program or because of some external events, like let us say there is a timer device and the timer has just expired, and now your program has to stop and some other program has to run, right? And that is an event which is caused by external element. Or assume that suddenly while running the program someone has pressed the key Control C, then your program has to stop, right? Which is an event which is caused by external element, right? Because of this IO, input output. Got it? So whenever such an exception happens, then automatically something called as interrupt flag will be set, or that is a signal, right? Then the CPU will receive a signal. Now in response to that signal, CPU is going to call a new program which is called as interrupt service routine. Now this interrupt service routine will take the concerned steps. For example, if you are trying to access a code which is not in your part, generally that is a virus, right? Then your CPU has to stop it and give you a message saying that this is an illegal activity which you are trying to perform, or you are not allowed to perform that. Got it? So whenever anything like that happens, our operating system will directly call our CPU itself can be hard coded using the hardware in such a way that a new program will be called. Now you might think that since that new program is also a kind of sub program, which means your main program, from your main program you are going to that new program called interrupt service routine, and after executing it, since you are coming back, it is exactly similar to the subroutine. You might think that interrupt and subroutine both are actually same, but then there is a difference between a subroutine which you have written and the interrupt service routine which is executed in response to an interrupt. So let's see the difference first. Let's see what the difference exactly is, and while looking at the difference itself, we shall see what are the types of interrupts and how they are handled at hardware. Later again at IO we shall look at interrupts one more time, but here let me give you a brief overview. Since we are talking about call and written instructions, this is the best place to talk even about interrupts which look like a subroutine. Okay, now let's see the difference between subroutine, which means a program which you wrote, and the interrupt. Interrupt means something which has happened because of some exceptional condition. Okay, now let's see it one by one. So point number one, when will subroutine be executed is, it will be executed, or subroutine will be the transfer of control. Let's say transfer of control in this case is initiated by call instruction, right? So what is call instruction and what happens when you do that? We have seen all this, isn't it? Here interrupt, it is initiated because of a signal generated, right? So that is a hardware signal. So it is mainly because of an instruction which is software instruction, and that is mainly because of the hardware signal, right? So what happens is, whenever CPU is trying to execute an instruction, how will an instruction will be executed? You fetch the instruction, decode the instruction, and perform the operation given in that, and then write back the result. So this is entire thing is called as instruction execution, let us say. Now this instruction execution is a kind of atomic operation. So while you are executing an instruction, CPU will never stop in between. After one instruction is completely executed, then only it will look at the external signals, or it will look at a flag which is called as interrupt flag. In case if that interrupt flag is 1, it means that there is an interrupt. Only in that case CPU will check for interrupts. So remember this point, it is very important. CPU will check for interrupts only after the execution of the instruction, not in between. Got it? So once the complete execution is over, CPU will check for it. Now whenever it detects that the flag is set, which flag? Interrupt flag is set, then it will get into a hardware cycle. Rather than a software cycle, it will get into a hardware cycle. So exactly what does it mean? We shall look at it when we go into the design of the CPU. There I'll tell you what is software cycle, what is hardware cycle, or in fact we shall discuss what is a cycle. So what is a fetch cycle, what is execute cycle, like that. Okay. For now, just think that whenever CPU finishes executing one instruction, it will look at this flag which is called as interrupt flag. If it is set, automatically it will trigger hardware, right? Now hardware will take control of the CPU, or for that time no instruction will take place, no user program will run. It will directly, CPU will trigger the hardware, and hardware will perform certain actions. Let's see what are they, right? And before going to this, now what are the signals, or what are the types of interrupts that we can think of? There are 3 types of instructions mainly. So one instruction is generally external interrupt. So external interrupt, or sometimes it is also called as hardware interrupt. It is mainly caused because of the hardware devices. So what are the examples of these external interrupts is? One is IO devices. Sometimes you might set something called as write operation, and then once the write is over, the IO device will disturb you, right? So don't worry about it. This IO devices, how will they work with the interrupts, we shall again discuss once we go to IO devices. I'll get back to this point again. Okay. And the other one is timing device. So sometimes you might be implementing something called as round robin scheduling, in which every program is supposed to execute only till some, let us say 2 nanoseconds. In that 2 nanoseconds, if it is not able to execute completely, it has to stop execution and the next program has to start. So for that reason, timers will be set. They are also called as timing circuits or timers. Okay, so you can think of it as timer devices. Timing might confuse you. Let's say timer device, right? And then what are the external devices generally you can think of is sometimes power supply circuit. What happens is, whenever you try to switch off a computer without shutting down, then some of the most important things have to be saved to the permanent memory, otherwise they will be lost. In that case, what happens is, immediately when you press that power button, then in that nanoseconds or milliseconds gap by which the computer is going to get off all the information will be moved from your RAM into the hard disk. So that is why recently in computers you might even see this. Even if you have this power loss and if you don't have any backup like UPS, sometimes you will be able to get the work which you are doing. Sometimes it might not be possible, but most of the times our computer will try to save the work, and it is also a result of the interrupt which will be caused if there is any power fluctuation, right? And the other one is internal signals. So internal signals are nothing but, internal interrupts are nothing but, these are caused because of the activities that your program is doing. For example, your program might try to divide by 0, right? Which is an exception, which is not normal. Then you are supposed to, or your operating system is supposed to handle this, right? Or sometimes a register might overflow, right? Or sometimes what happens is protection. So you will have, every process will have certain amount of memory to work on, and you are not supposed to access any memory which is outside that, and your program might try to access it by using absolute addressing. In that case, protection is important, and in case if you violate it, then also that is going to protection violate, and it will cause some interrupt, right? And similarly, you might have you might write a program which is not having any anchor condition or halt condition. For example, if you are written a recursion program, and in that recursion program you didn't specify any condition where the recursion program has to stop, then what happens is you'll continuously be calling the same function, right? So theoretically you have to follow an infinite loop, but practically this program will run until the entire memory stack has been taken up. I told you that memory stack is going to be used in function calling in order to save the written address, right? Mainly written address. And when you have infinite number of function calls, then the stack is going to be filled up, and when there is a certain limit, if you cross that limit, then that is nothing but the memory stack overflow, right? So that is a condition, and that is also has to be handled. So stack overflow is also a condition. So there are various other conditions like this. I am giving you a few examples, okay? And sometimes you might want to execute something or a piece of code which is not a part of your program but a part of operating system. For example, in C programming language, if you use printf is nothing but a system, this normal function call, which is nothing but a user function call, right, which will be implemented in the library. But then in order to execute printf, inside printf there will be a system call called as write. So system call will be discussed in operating system. I'll again go back there and I'll discuss about system calls, but just try to understand this. Write is a piece of code which will be present in the operating system, which will be called by printf. Printf is a software or a piece of code which is either written by the user or provided as a part of the library, right? And therefore when a user calls printf will internally call write. Now write is a piece of code which is present in operating system, and in order to execute anything that is in operating system, you are supposed to change from user mode to supervisor mode. So supervisor mode is nothing but a superior mode. Whenever you try to execute anything which is present in operating system, you have to change the mode from user mode to supervisor mode. The reason is, when you are executing something which is related to operating system, you should never be disturbed until you finish it. Got it? So in supervisor mode, all the interrupts will be disabled. So we shall get into this again in the system calls later, but here let me just state few things so that you'll understand this concept briefly, okay? So what I mean to say is, there are third type of instructions which are called as software interrupts. So these software interrupts are caused mainly because of the user functions calling the system calls, right? System calls. So these are all the events which are going to generate interrupts. Now after executing any instruction, we are going to look at the interrupt flag, and then automatically hardware will be triggered. Now the hardware will know what to do, right? Now what is the main difference between subroutine and interrupt service program is ISR, interrupt service routine is, let's see this. Okay, so in this case what has happened, the second point here, in this case once you know that, once you are going to call, the main thing that will be stored is PC, isn't it? Program counter is saved on the stack, right? That memory stack. So why should this be saved? Because once you come back, you should remember from what point you are supposed to execute. That is why you are going to save it. But in case of this interrupt, it is not just the program counter that has to be saved. Along with the program counter, you are supposed to save the context of the processor, right? So what is the context of the processor is, one is definitely program counter, right? And the other one is program status word. So program status word is set of all flags. Because why should you save even these flags is, while executing this as a response to this interrupt, when we get into a special software which is called as interrupt service routine, when you execute it, most of the flags might change, or at least one flag has to be changed. I didn't show you one of the flags which was not very important for our discussion, but it is present in most of the computers or all the computers. That flag is nothing but mode. Either it is user mode or it is supervisor mode. So till the point where you get the interrupt, you will be in the user mode, and once you get the interrupt, you have to go into the system mode, right? So therefore various flags will change, and definitely mode will definitely change, which is also a part of the program status word. Got it? And along with this processor registers. What are processor registers? All the general purpose registers present in the processor other than program counter also have to be saved. The reason I explained you in the earlier video, if you remember it. So we don't want any of the processor register to be modified by the interrupt. And then if they are modified by the interrupt service routine, we don't want to use the modified values once we come back to our main program. That is why all the registers have to be saved on the stack. So everything that is related to processor or process state, which is also called as context, will be saved on the stack, and later everything will be returned to the same state when I return from the interrupt. Even at the end of the ISR, interrupt service routine, there will be a call which is called as return from interrupt. When you do return from interrupt, it is going to load program counter with whatever value it was there earlier. Along with that, it will restore the program status word. Along with that, it will restore the registers. Same way how the return worked here, return for interrupt will work there. Got it? And now one more thing worth mentioning here is, who will do all this? So there are two ways it can be done. Sometimes some of the computers hardware itself is designed in such a way that whenever there is an interrupt, everything will be stored automatically by the hardware, or first hardware will just transfer the control to the interrupt service routine. Right? How will it transfer the control? By placing the appropriate address in the program counter. In the program counter, let us say you are here, and then suddenly an interrupt has occurred, right? At this point, hardware will load program counter with the address of a service, right, which is nothing but interrupt service routine. Let's say it is here. Then suddenly your program will go there, your program execution will go there. Now some part of interrupt service routine initial lines will contain the code which will move all this into the memory stack, right? And at the end it will contain the code which will move it back, which means after the interrupt has been handled using this code, the end part of it will move the entire thing into their appropriate places and then give back the control to the program so that it will continue with its normal execution. So some processes hardware will do some part, which means hardware will just transfer the control and interrupt service routine will do all the required things. In some computers it is designed in such a way that our hardware itself will transfer everything into the memory stack, and then it will go to the interrupt service routine, and interrupt service routine will not do any movements here. It will directly try to handle the error, and after that it will directly give the control to the hardware, and hardware in itself is designed in such a way that everything will be restored, right? Both the things are actually in practice. Some people are leaving everything to interrupt service routine, some people are leaving it to hardware, right? So anyway, there will be no questions asked on that. Okay, just for your information I'm giving you that. Got it? And even some computers are designed in such a way that there is no need of storing the context at all. So how is it designed is, some set of registers are reserved for the user mode and some set of registers are reserved for the supervisor mode, and whenever there is an interrupt, you will switch from user mode to supervisor mode. Since both the modes are using different registers, there is no need of saving the context in order to execute a in supervisor mode, because already supervisor mode is using different registers. Got it? So there are various things which are there in practice. Coming to the implementation, but whatever it is, this has to happen. All this have to be saved somewhere. However you do it, it doesn't matter. Okay. And the third important thing is effective address. So effective address of our effective address has to be stored into a program counter, and now this effective address is being computed or is being provided by the call instruction. This is very important. Okay, so when you are calling a subroutine, you know where to go. That is why effective address is computed by the subroutine itself, or you are going to provide this effective address in the instruction itself. Therefore, by using this software, we are getting the effective address, and which will go into the program counter. And in this case, effective address is provided by hardware, which means you are not going to get the effective address by applying any of the addressing modes which we discussed earlier, or there is no instruction which will give you the address. So the address will be determined directly by the hardware. Hardware will compute the address, and you are going to put that address in the program counter. Therefore you are directly going into the instruction service routine. Now what address will be given by the hardware? Again, it depends on the implementation. Some implementations will see what type of that interrupt it is, and according to the interrupt there will be various interrupt service routines in the computers, right? So some computers will have one interrupt service routine for every type of interrupt. Therefore some computers might use, depending on the type of interrupt, they will look at which interrupt service has to be called, and that particular interrupt service routine's address will be loaded into program counter, right? And some implementations, what they do is, they will directly go to a common interrupt service routine, and then this common interrupt service routine will decide which interrupt service routine to call in order to handle that specific interrupt. So whatever the way it is, always the interrupt, in this case of interrupt, hardware is going to provide you with the address. So about that implementation, let's see if you get any example during the hardware design. But anyway, these are the concepts that you are supposed to remember. Implementation may vary from computer to computer. I hope you are getting the difference, right? What I mean to say is, in most of the computers, for every interrupt there will be different service routines, right? And depending on the type of interrupt, that particular routine will be called. Let us say the interrupt is because of memory overflow, right? That stack overflow, then one particular type of interrupt service routine will take it, right? Let us say it is because of the IO, then one particular type of interrupt service routine, right? And how are they provided? They are called as vectors. So we shall get into this topic later when we discuss about the IO and interrupt together. Okay, so about the addresses, how are they being provided? So either they will be specific addresses will be provided, or directly one address will be provided, and when you go to that address and try to execute that routine, then that routine will direct you to the interrupt service routine which is appropriate. Got it? So both the implementations are in practice. We shall learn more about these interrupts when we get into IO. There you might understand even better. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.